Okay, we're going to go ahead and get started. This is the Understanding SQL Commands and Injections lab for security compliance class. I'm going to run through the lab really quick because the SQL part of IT is confusing to a lot of people, and I wanted to cover it thoroughly so that you understand what a SQL injection attack is and why we have to really monitor our software development to make sure that flaws that can be taken advantage of by SQL injection aren't present in your web applications. So to get started, we're going to go ahead and log into this Kali box. So switch over to the Kali Linux machine. Remember, when we log into Kali Linux, we're always going to log in as root with the password TOOR, which is root spelled backwards. We've got our terminal window. And so the first thing we're going to do is start a SQL server on this Kali box. In order for us to understand SQL, we're going to do a little bit of hands-on in this lab. So we need to go ahead and start the SQL database. We type service MySQL, which is the open source version of a SQL server that we typically use on Linux. There's other ones, but if we want to use Transact SQL, then we're going to use MySQL. So we're going to start that service. That starts the daemon so that we can connect to it and do stuff with it. Now we're going to go ahead and log in. You'll find once you start doing stuff in IT that SQL is ubiquitous. It's pervasive. It's everywhere. Almost every web page, almost every function of IT hits some kind of database somewhere in the background and grabs information for us. So a SQL is, you can compare it to an Excel sheet where it has rows and columns and tabs, but it's much more robust than a spreadsheet. It allows us to store lots of information and do queries really fast, do ask questions of our data really quickly. So that's the reason I included this lab, was that we need to understand what SQL is, because if you're doing auditing or you're doing pen testing, it's a big piece of making sure that your organization is secure. Once we're logged in, what we're going to do is our information is going to be separated into little compartments called databases. So I'm going to go ahead and show the databases. Whenever we use a transact SQL statement or SQL statement, we're going to make sure that we put a semicolon at the end of it. That's like an execute symbol that tells the interpreter to go ahead and execute that command. As we can see, there's already 3 databases in our brand new database that we've never touched before. So these are the databases that keep track of the security in our overall SQL database. So we have a database called Schema that has the rules about what can be contained in some of the tables. We also have performance counters, so we can measure the performance of the server. And then MySQL, I believe, is where it keeps all of the security information about all of the other tables and databases. So those 3 are there by default. If you're familiar with Microsoft SQL Server, sometimes there's even a sample table, a sample database in there. If your database, if your SQL Server has that, you want to probably get rid of that. We don't like to keep vendor supplied example databases in our system because it gives people, hackers, a foothold. They have some information about our database Whereas if we took that sample out, that sample code out, it wouldn't be there for them to attack. Okay, so these are our databases. What we're going to do in today's exercise is we're going to go ahead and make a new database so we can start getting used to these commands. So you should know some simple SQL commands just to understand what they do. You don't have to use this. You don't have to become a programmer, but able to audit it and able to pen test it, you need a little bit of knowledge about it. So what we're going to do is go ahead and create a new database. And this database is going to be called test. Remember, we always have to put a semicolon at the end of our commands. It says query OK, one row affected. That means it added a database to our overall database, right? Our database system, our SQL server. So we're going to go ahead and do our command again where we say show databases. You can access previous commands by hitting the up arrow, don't forget. So you don't have to keep retyping the stuff over and over and over. Notice now we have a new database in here called test. That is the product of the command we just typed, create database test. So we can see it worked. Now we're going to tell the SQL server that we want to use that database. So we just say use test, remember semicolon. We switched our database, so now when we run commands, it's going to be run on the test database. So we've targeted that database so that anything that we type from now on is going to be done. Any commands we type from now on are going to be executed on that test database. So first thing we need to do is understand inside of a database, the units of information or the containers that we have inside the database are called tables. So what we're going to do is we keep information about a certain subject in a database together, right? We're grouping it. And then further inside of the database, we're also going to group our data by subclassifications or make little subunits inside the database. And that keeps our database lean. It keeps our database so that when we run commands, the commands run really fast. We don't want to have a giant table with everything in it. The SQL Server would be very slow if you did that. And there's a whole class you can take on performance and making sure that these tables are small and lean. So we switch to the test database, and now we're going to say show tables. And there should be none in there, because we just created a database. What we're going to do now is we're going to go ahead and create a new table. This would be analogous to creating a worksheet inside of your workbook in Excel. So if you want to connect that in your head. Notice my prompt has changed also. It tells me that I'm using a test database. Whereas before, when I looked at the prompt, it said none. That means none of the databases were targeted for commands. Now that I've said use test, the prompt has changed so that anything I type, any of the commands I type, are going to be executed in that particular database. So let's go ahead and create a table. The syntax for that command is create table. The name of the table we want to give the name we want to give the table, so we'll call it users. So we're probably going to store user information in there. Name, variable character or varchar, and what that's doing is it's giving it a data type. So it knows exactly how much memory or disk space to set aside for that field, that column in our table. We have another column in our table called account, and it is going to store a number. So integer, that's a data type. Balance. When we keep balances, we probably don't want to keep a whole number. We want to keep a fraction of a number. So we're going to say it's going to be a decimal. And making sure that these data types are correct from the beginning is very important for performance reasons, and also for just storing the what do you say, the exactness, or the I can't remember how to say it in math, the how many decimal points you can go up, you want to keep track of. Because if I'm keeping a bank account and I just keep an integer amount, how much you have in your bank account, then I can't keep track of the cents. I can keep track of the dollars if I use integer, but if I want to keep track of cents also, then I have to use a decimal. So I'm going to go ahead and hit enter and see if that worked. If there's any mistakes in here, it'll come back and tell you that it couldn't do it. I want to double check all my spelling. Okay. It says query OK. That means it executed correctly and that it created the table. Now if I say show tables, we can see that we have a table inside of our database called test, and the table's name is users. We see that right here. And it builds a little ASCII picture for you, so it looks more clean. What we're going to do now is run some SQL queries that actually put information into that table. So the keyword we're going to use is insert. So we're inserting a record, just like you're inserting a row into Excel, into the name of the table that we just created, users. And the values we want to add to that table are going to be John, comma 1, 2, 3. That's going to be the integer column. So it's going to insert John into the name column. So the order of these information that I'm typing in this command is important. So it's going to add the name John to the name column for the first record. It's going to add 1, 2, 3, the integer 1, 2, 3 to the account column, and then the balance is going to be $10. Notice before we hit enter that the first value I put in there, because it's text, we put these apostrophes around the outside, or quotes around the outside of the value. That's letting SQL know that that is text and not a number. So we need to make sure that we do that whenever we type a text field in SQL, that we use a quote. Don't use the quotation or double quotes. That means something else in SQL. I'm going to hit enter and see if it accepts it. Notice it says query OK. One row is affected. So now what we can do is we can run another command called select. Star means everything. It's like a wildcard. If you're familiar with regex in Linux, you've taken a NOS 120 class, you might have saw the star symbol before. That says everything. It matches everything. Users. Notice it has the row now that I just inserted. So here's the columns, name, account, and balance. And then we have the row with the user's name that I inserted, the account, and the balance. Let's take a break for a second and let me review a little bit about SQL. I'll flip over to my slideshow. So when we want to get information from the database, we always use this select command. Okay. So our command is always going to start with select. So we'll say select, and then we want to tell the SQL database what information we want to select. So when we say select, Notice we inserted a column called users in our database. So let's see. We had a table called users, and then we have columns called name, account, and balance. This is what we would put in our behind our select statement, the name of the column that we want to pull back. Most of the time we don't want to pull all of these columns at the same time. We might want to just pull a list of names. So we would say select name from, and then we put the name of the table in there. Right? So we say select name from the name of the table, users, where, and we give it conditions. So typically we don't want to return all of the rows inside of the database. What we want to do is just select some of them. So for instance, we can write a command, select name from test where the balance is more than $10. So that would be an example of one of these select commands. So a select command pulls information out of the database. An insert command inserts information into the database. So information that you want to add to a table, you're adding a new row in Excel, is insert. If we want to pull information out and run a report, maybe we don't want to look at the entire database, we just want to pull out some users, we use a select command. So select looks at information, insert inserts information. To give us a few records to play with, I'm going to go ahead and insert another row. And this is in the directions. Four, 5, 6 is my integer, and then 20. Don't forget your semicolon. It says query's okay, it affected one row. We're going to use our select again. Notice we have 2 records in the database now. We're going to create another table. So we're practicing all these commands. So to create new tables, we use the keyword create. We're going to create a table called personal. It's probably going to keep the customer's personal information or the user's personal information. The first column in that table is going to be called name. It's going to have text, so we put var char there, and it is going to be 30 characters long, up to 30. Remember, we want to keep that as close to the information that we're going to gather, that number. Because if we add, we're only keeping information that has 30 characters, but I put 40, we're wasting space in the database, and we don't want to do that. The next field is going to be called address. Next column is going to be called address, and it's also going to be text. It is also going to be 30 characters. That should be able to be long enough to put a number in a street name, probably. We also want to keep the information about their city. Typically, the name of a city is less than 20 characters long. And then we're going to keep their telephone number. And we're going to store that as a big integer. We're not going to put the dashes and characters inside of that phone number. I'm going to go ahead and hit enter, and we'll see what happens. All right. So now we created this new table. Told us that the query was okay. Let's run a command again called show tables. And we can see it indeed created a new table called personal. We're going to go ahead and insert some data into that personal table. Oh, typo. Remember, the order of these values matters. It needs to match the order of the columns in a database. Had a little bit of trouble there with the keyboard. So insert into personal values. We're going to say Joe. $13 Cemetery Lane. Oh, I forgot a comma after Joe. Remember, this is just like programming, so you need to have everything exactly the way it needs to be. You have to have attention. You have to pay attention to details. Green Briar. And then the phone number is 1313131313. We'll try enter. Notice the query executed okay, and it added a row. We'll insert another row. I used the up arrow to retype the first part of the query. We're going to add John. He's going to be 1313 Mockingbird Lane. The city is going to be Mockingbird Heights. And his phone number is going to be 310-555-2368. Remember, we need a semicolon. Let's check our work. Select star. Remember, that means select everything from personal. Notice it has the information that we inserted in there. So here's some samples that they're going to get you to do, some sample queries, so that we kind of understand how to write a query. First thing we're going to do, we've got all of our data in our tables now. We're going to say select name balance from users, semicolon. Notice it returns the name and the balance of the users. It's not returning the other column. The other column was account, right? So it's not returning that account number like it was before. It is, instead of us typing a star, which means all the columns, we're just going to return the name and the balance. You might not want it to return all of that information on the screen. Remember, we need to enforce need to know. And if there's extra information on the screen, then people can use that information. So maybe we just want to show the name and the balance. We don't want to show account numbers on the report. That would be an instance where you would, instead of using the star, you would just use select and balance. Another example would be select name and then telephone. From personal. Notice that gave me the name of the person and their telephone number. It did not show the address of the person. Same thing. We might not want it to show up on the screen. One of the cool things we can do with SQL is we can write a query that gets information from multiple tables. So I can have tables with their personal information. I can have tables with their balance information. I can have tables with their social security number information. And we keep those in separate little buckets, little tables. And then we can run a query that retrieves information across all of those tables, or if you want to say worksheets. So I say select, and then I put the name in the table where the information is coming from, and then the column. So I'm pulling the name from the users table. I'm also going to pull the balance from the users table. And then I'm going to pull a telephone number from the personal table. The reason we put the name of the table in front of the column that we want to return is so that it's very clear to the SQL system which table we're talking about. We'll say telephone from the users table. So the primary table that we're pulling this report from is going to be the users table, but we're going to join the other table called personal to the users table, so we can pull information. That's going to be the relationship between the two tables, is going to be the name. So we're going to join the users table and the personal table. And the way we're going to make a relationship between those two tables is we're going to say the users column called name is going to equal the personal table's name column. So it's going to use these two fields in the two databases to match the user accounts. Let's see if it works. Notice it pulled the name and the balance from the users table, and then it looked at the name of the person in the users table, and then it looked at the name of the user in the personal table, and it matched them based on that, and then it pulled their telephone number from the personal table. So that's a more complex query. So these queries can get very long depending on how many tables you're pulling from and what kind of relationships they have inside of those between each other. But the tables have between each other. We've talked about adding information. We've talked about looking at information that's already there. Now we're going to talk about removing information from the database. To remove information from the database, we're going to use the delete command. We're going to tell it to delete from the personal table. Where the person's name equals Joe. So I'm going to erase that, what we call a record. Notice it says one row was affected, and now we're going to do a select from that table. Notice the information is gone. If I scroll up a little bit, we can see we had 2 records in there. Now we only have 1. To get rid of an entire table, we use the drop command. So delete is to delete records or rows in the table. To delete the table altogether, we say drop table personal. Table's gone now. If I run that command again, select all from personal, I should get an error. Yep, table doesn't exist anymore. We'll drop the the next drop command we want to review is the drop database command. This will drop the entire database, not just a table, the entire database. So this is a very destructive command. We got to be careful with the drop database command because we could erase a whole database with it. Notice my database no longer says test, my database says none. And if I do show databases, notice the test database is no longer there. All right, let's take a break for a second and scoot over to back my my slideshow. So remember, a select command is going to select information from a table. So here's an example of a table. This is going to be the product name. Okay, so P name, the price, what category the product is from, and then who manufactured that product. So this is a table of stuff we're selling maybe. Right? And we run a SQL command called select. Remember what the star means. It means everything from product, which is the name of this table, where the category equals gadgets. So maybe I'm shopping and the customer wants to only see things from the gadget category. He doesn't want to see stuff about photography or household things. So that's what that select would do. It would change the client's web page or screen that he's looking at and filter it. That's an example of a SQL query. Some of the things that I haven't talked about that you need to remember about SQL is that the commands are insensitive. What that means is I typed a select command to pull records from the database. If you capitalize it or make it lowercase or first cap, it doesn't matter. It all sees that the same. Okay? Product with a capital P is the same as product with all lowercase. So the commands are case insensitive. The values are not. So when I'm doing a search for maybe all the customers that are in Seattle, when I type the where clause and I put where in there, so to limit what records are coming back, I want to make sure that I use the correct case. Remember, when we're typing text, we need to use a single quote, not a double quote. So those are just some tips to help you remember how to type those commands. If you type it wrong, then you're going to get an error and you just need to fix it. If you type this information wrong where we have values, like in a where clause, you might get data back and it'll just be wrong. So you won't get a syntax error when you do that. That's more of a logic error. One last thing before we go back. When we work with these websites, web-enabled databases, we typically have layers of the application. So we have a web server typically at the top layer right here. So this presentation layer is going to have a pretty screen, it's going to have pictures, and it's going to have customer information. what's actually happening when somebody goes to the website and types, get my sales total. They click a button, a GUI button, and want to get the sales total. There's a back end right here. So they might have a different computer that has all of the logic for the website in it. And then we're going to actually have our databases on a different system on the back end. So there's actually 3 layers of computers put together to run this particular web application. So I just wanted you to realize that typically your web server is not your database server. You usually have 2 different servers running. And the web server will send requests from the web server box through your network to a database server where it'll get this information out and send the information back to the web server so that it can send it to the end user. So a lot of people don't realize that they have all of these layers in between you and your data. We do that because it makes the application work better. When we do updates to the application, it's not as big of a deal. It also enforces integrity and security. So you'll see that there's layers to any web application that you see. Think, for instance, Moodle. The Moodle server that you're taking your class on. You have a website you go to and you look up your assignments and information. When you pull up one of those pages, what's actually happening is it is hitting a database somewhere on the back end and getting that information about your grades, getting that information about your PDF file that you're reading, getting your coursework. When you submit an assignment to Moodle, it actually sends the assignment and it stores it with an insert command inside of our database. So it'll say insert my classwork. It'll add it to a table inside of the database. So you're actually writing to a database when you submit your homework. All right. We're going to switch gears a little bit now that you have like a crash course in SQL. I don't expect you to know how to do it exactly. You just have some idea what SQL is now. It's a scripting language, just like Python. So when you take your Python class, you'll kind of, if you've already taken it, you might have seen some of these queries already. But it's similar to Python with this as a scripting language. So what we're going to do is we're going to open up the web browser. So we're going to pull up a web browser. And we are going to connect to a server inside of our pod. And the server's IP address is 192.168.68.12. Okay. This is called the server is running a version of Linux, a version of a web application called OWASP, OWASP. And what OWASP is, it stands for Open Web Application Security Project, and the project was created to teach students how to write applications that cannot be hacked. We found that most of the applications on the internet had very poor programming and large vulnerabilities in the application, the web application that companies were turning out. So they started this project to teach web developers what not to do. And part of this distribution of Linux that they put out is called the Broken Web Applications Project, or BWA. And it actually gives us a website that has vulnerabilities in it so that we can exploit those vulnerabilities and see exactly how people will break our web applications or hack into our systems. So that's what this server is. It gives us a bunch of web applications to hack and practice on without breaking somebody's real system. So you can download this VM from the OWASP website and put it in a virtual machine on your computer at home and have at it. See if you can hack it. See if you can figure out how to break into it. It is intentionally vulnerable. So we're going to scroll down, and the project we want to use for this particular exercise is called the Damn Vulnerable Web Application, DVWA. So we're going to click it. Pulls it up. Notice it looks like a typical website that you would log into. We're going to go ahead and log in. Username is admin. The password is also admin. Okay. Tells you about the web app. Tells you about how to use it. Tells you that it's vulnerable. You shouldn't upload it to a live system. We're safe because we're in this pod. Nobody can get to our server. But if we put this out on the internet, somebody will come by and hack it. We're going to click on the SQL Injection. And then, so it gives us a web page that's vulnerable to a SQL injection attack. Here are some references to teach you about SQL injection attacks if you want to look at them. Right. So the logic for this is probably a select statement. So we type a user ID in here. Let's flip back to the preview. So on the back end, it's probably saying select the row from a table where, and then that's where this is going to show up. Select everything from a table where user ID equals whatever they type in here. So the user has this field that he can control the SQL statement, right? So typically what I want to do is type a user ID in there, right? And it's going to match one of my user IDs. Maybe I might use the user ID called admin. Notice it doesn't work. Because it's looking at the fields in the database, and maybe it's not looking at the fields like it should. I can take this box, and since the web developer doesn't check what I type in this field right here, I can type SQL commands in it and get it to return more information than it should. For instance, I can put something in here that would give me information that the developer didn't intend for me to have. So I can say 1 equals 1. And inside SQL, that equal sign means something. So I'm going to submit it. Notice what happened. It's returning one of the rows in the database. Okay. So the SQL command it ran was select the first name and the surname from a table where the user ID equaled 1 is what it ran. Right. So I can, once I figure out what type of query you're running, I can add extra keywords from the query language that are not supposed to be in this box. Right. Since the programmer's not checking to see whether I'm cheating, I'm typing SQL commands in this box. I can type all kinds of specially formatted SQL commands and hit submit. Notice I got it to dump all of the users out. That probably wasn't the intent of the application developer. Now that I know that the developer's not checking, when I'm typing in this box. I can keep on adding more fields to my query, SQL commands, that's going to give up more information about the database. I'm going to type a union command, and I'm going to select information from another table. Pound symbol. All right, let's see what that does. Notice it kind of looks the same as what we had before. It added a little bit to the end, but look what it did at the end. It gave us some extra information. So that gave us information about the name of the database and the email of the database administrator by typing that command, that specially crafted command. So I could sit here all day trying different SQL commands that are not supposed to be typed inside of this box. So this isn't what the author of the web application intended. But since I know he's not checking what I type in here, I can type all kinds of commands, like this version command. This version command will tell me what version of database he's running. Let's try it. Notice it says he's running Ubuntu. So now I have a target. I know what version of the operating system he's running, and I can go look for a vulnerability for that particular version of the operating system. Now I know he hasn't updated his web server. So I can go look for vulnerabilities for that version of Linux. Okay. Try another one. So these specially crafted SQL commands are coming from the lab instructions. You could sit there and try to figure some out for yourself to fool around and figure out stuff about the database on the back end. In order for you to do these attacks, you would have to be pretty good with SQL to know all these commands. Okay, looks like I might have typed something wrong. So let's go back. Tables, information schema. No. Make sure that's all right. 1 equals 1. Union. Select null. Table name. From. Oh, look. Information. I spelled information wrong. It's not information, it's information. Submit. Notice it dumped the original information, but look what all the other stuff it dumped. It dumped the character sets that the server's using. It dumped the privileges from the tables. So it's showing me all of the tables in a database. So there's a table called guestbook. There's a table called users. So now I know the name of the table. I can even cross over and use the table called guestbook if I wanted to. So now that I know there's a table called users, I can start targeting the users table. So we say, or 1 equals 1. Union I'm going to select the user column and the password column from the users table. So what I'm doing is I'm crossing over into another table that the author of the website didn't intend for me to cross over to. So I'm running queries on a different table in the database. And this particular table in a database is called users. I'm going to go ahead and hit submit. So look what it did. After the table, it went ahead and outputted all the users and their password hashes. So now I have all of the usernames for this website. Remember the first form I logged in? I logged in as admin. Now I can log in as Gordon B. I can log in as Pablo. I have all of their password hashes now. I can go and break and come back and get into the website. And this list of all these password hashes is what they want you to use for the screenshot. So the last part of the exercise is using a different utility. We're going to use a utility called SQLmap, which is an automated utility. So we could poke around and we could test all of these queries to find out information from about the database, or we can use an automated utility to go through the database and figure out the map of the database and what's in there. So what we're going to do first is, in order to use SQLmap, we need to have information about the web browser. So we're going to log out of the DVWA page. So click log out. Back to the login screen. At the login page, we need to get the cookie created there in your login. We have some extensions on this browser that allows us to get that cookie information. We're going to click on Web Developer. And then we're going to go and click on Network. Gives us a window down here so we can find out information about the web page. We'll go ahead and log in again as admin. Notice as we travel around the website, it's recording everything that we're doing. The pages that were sent. Here's a post method, there's a get method. So we can use these built-in developer tools inside of Chrome and inside of Firefox to monitor a web application to try to figure out how it works. It's a key to using. Using that is like key to doing these capture the flag events when we're doing National Cyber League. Use the developer panel. Most of the problems can be solved using the developer panel for the capture the flag events. So we see this post event right here. So what we're going to do is click on that post event. It's going to give us information about it. When I posted my username and password to the website, it created a session that created a cookie. So what we're going to do is find that cookie. So the cookie it sent information about it. It was low security, and it has all the information about it. They want us to double click the text after the word cookie. Press Control A to select all of it, and then Control C to copy it. If you're on a Mac, it would be Control A and Control C, or Command. I'm sorry, Command A and Command C on a Mac. On a PC, it would be Control A and Control C. Okay. We're going to flip back over to the terminal. Looks like my C button is stuck. Okay, let's go back. All right. We're going to use the utility called SQLmap. Typo. The H allows us to get the help screen. So that's what we're looking at now, the help screen for the utility. Okay. So it shows us all the information about the SQLmap utility. We're going to use the options SQLmap, one called U. So that's going to be the target URL. So that's the website that we're trying to attack and get a map of their SQL database. Right. It also wants us to put our cookie there so it can match the session, so that it passes the authentication information to the website. If I didn't pass the cookie, then I would have to have some kind of way to pass the username and password to the utility. So the cookie is the easiest way to do it. So we're going to paste that cookie that we gathered from the developer tools into this command line utility. And then we're going to use the dump command, and it's going to dump the table information from the database. So instead of fooling around with the form and trying to figure out the SQL commands and the SQL syntax to get the information we got when we kept running queries against the database, this is an automated utility that'll do it for us. All right. So we'll start typing this now. It's a long command. -u, the URL of that page, which you could probably go back and get. Let's see. No, so let's just type it. http://192.168.68.12 DVWA Let me sure vulnerabilities is spelled correct. Vulnerabilities, right? Okay. SQL I bind question mark ID equals 1 ampersand submit equals submit close quotes dash dash cookie equals open quotes paste still doesn't want to do that. Okay, so it did it now. Close quote. Let's see. Dump. Let's see if it works. Testing, page not found. Since it says critical error, page not found, we're not going to continue, so we hit no. I probably have a typo. I'm going to Control C to break out of the script. And then I'm going to take a look at my command again, make sure I didn't make any mistakes. So we've got the right IP address. DVWA vulnerabilities SQL underscore I put bind instead of blind, so let me fix that, blind, and then I'm going to hit enter. We didn't get a message that time, so maybe it's going to work. It says it looks like the backend is MySQL. Do you want to skip payload specific for other DBMSs? And the instructions say to click yes. Do you want to include all tests for SQL? We'll say yes. And again, this is coming from the directions. Do we want to continue? They say yes. We're going to say no to that one. We'll say yes. Do you want to crack the hashes it finds with a dictionary attack? It said yes. We want to select the default word list, so we hit enter. Do you want to use common suffixes? It says press enter to skip it. Enter. So it's cracking all of the user and passwords inside the database. Okay. And it says it put those passwords in a folder. Right. So we're going to scroll up a little bit and we can see that it dumped out the user and the password hash, and then it also decoded the password in the brackets. So this hashed password is admin, this hashed password is ABC123. So it actually broke all of the usernames and passwords for this website using an automated utility. Remember what we did before, it gave us the hashes. This utility will actually break the hashes and gives the original password back. This is what we want to take a screenshot of to end the lab and get credit for the lab. If you have any questions about the lab or you get stuck, send me email. I hope you enjoyed the lab and you learned a lot from it.